Hello grade 9s, welcome to today's Maths Lit video lesson. I hope you guys are all well, staying safe, staying indoors and staying warm. The last thing you guys want to do is catch a flu while winter is coming. With the sneezes and the sniffles, people might think you have COVID or something and mistake you for one of the infected. So hopefully this lockdown ends soon and we can get back to regular lesson scheduling. And in today's lesson, we'll be going through volume and capacity. You'll find this on page 225 of the textbook. Now, this section builds on the work we did in the previous section with area and perimeter. So, area and perimeter dealt with shapes in the two-dimensional plane, okay, like on a flat surface. However, volume and capacity deals with objects in three-dimensional space, like in real life. And really what volume is talking about is how much space this object occupies in the three-dimensional space. So we're not going to go too crazy with this section. The main shapes or objects, that we're going to be focusing on are a rectangular box, a cylinder, so like a Coke can, and a prism. So a prism is like a wedge of cheese. So how do we calculate volume? It's really easy. We just need this formula over here. Volume equals area of lid times height. So if you're ever struggling with volume in grade 8 and are haunted by it, today is the day when we reverse the curse. So let's see what this formula is telling us. So we're going to look at this cylinder over here. The cylinder is, it's like a circle at the top and it's got a height. So you can think of like a Coke can or a Pringles can. So the area of the lid is a circle. Okay? And if we take this circle and we add it all the way from the top to the bottom, if we go like this, we get the entire cylinder. So all we're doing is taking the area of the cylinder and timesing it by the height, getting all these cylinders from top to bottom, and that's going to tell us the volume of this shape. Okay, same story if we're looking at a box. So in this case, our lid is this square or rectangle at the top, and we're taking it, when we times that area by the height, we're getting all the squares from top to bottom, and we specify the entire box. Okay, so in this case, if we put in some values, say we call this 3, this side 4, and this side 7, then the area of our lid equals to 4 times 3, which is 12, and our height equals to 7. So our volume, I'm just going to call it V, equals area of the lid, which is 12, times the height, which is 7. So area of lid times height, and that gives us 84. Okay, now you guys can probably guess what I'm going to be saying for the prism, the volume of the prism. So a prism is like our Toblerone bar. It's got a triangle for the lid. So the volume in this case is going to be the area of this times by the height. Okay, so let's look at some examples. So the examples I've chosen are from exercise 19.2. You'll find this on page 227 of the textbook. And we're just going to look at question 1. So if you turn to that page, you'll see we've got a whole bunch of shapes. We've got a cylinder, a cube, a box, and a prism. And let's start off with the cylinder. Let's go in order. So for 1A, number 1, I'll redraw this. So we've got our lid, which is a circle at the top, and they give us a value for the height. The radius is given as 1.8 meters. So 1.8 meters is quite big. So this cylinder would probably represent something like a JoJo. So the area of the lid is the area of a circle which has equation pi r squared. Okay, should be familiar with that by now. So we already have the value of the radius, luckily. So we can just put in pi times 1.8 squared. Okay, let's see what this gives us. 1.8 squared equals times pi. So I get 10.18, and our unit meters squared. The value of our height is 2.5 meters. So now our volume is going to be the area of the lid, which is 10,18, multiplied by the height, which is 2,5. Gives us 25,45. And now what is our unit for volume? So the unit for area was meters squared, and the unit for height is meters. So we've got a unit for meters squared, and we're timesing it by a unit for the unit for length. So this gives us meters cubed. Okay, you can check this with some numbers. If you have 4 squared times 4, we know that 4 squared is 4 times 4. And if we times it by another 4, now there's 3 of them. So that gives us 4 cubed. So that's always going to be our unit for volume. It's going to be a cubed. And if you're struggling to remember that, remember volume is dealing with 3 dimensions. So there's going to be a little 3 there for our unit. Same story with area. Area deals with 2 dimensions. So that's why we have meters squared. There's a little 2 there for our unit for area. Okay, so let's move on to 1A number 2. That's a cube. Okay, the cube looks something like this, and the information, how we know it's a cube is that everything is equal. Okay, so like a cube is like 6 squares put together. Maybe look at a dice if you want to see an example of this, or like a Rubik's cube. You'll see we have 6 square faces. So because all the sides are equal, we just need the value of one of them. So that's given to us as one of these sides is 7,2 centimeters. So if we're trying to now work out the area of the lid, it's going to be the area of that square at the top. Area of lid. And the area of the square is going to be 7.2 times 7.2. Now I get 51,84 units meters squared. So our volume is now the area of the lid, which is this, 51,84. Sorry, it's not meters squared, it's centimeters squared. And we're going to take the area of the lid, which is this, and times it by height. So we times this by 7.2. Our height, because all these sides are equal, our height's also going to be 7.2. I get 373,248. I'm going to round it to decimal places. So instead of the 48, it will round up to 50. And don't forget our unit, centimeters cubed. Okay, next shape we have this pink rectangular box. I can't really think of another name than box. I don't know if there is one. Let's see in the textbook what they say. Oh, they call it a cuboid. Okay, and then the first shape was a regular cube with all the sides being squares. Okay, so I'm just going to call it rectangular box. You guys can call it cuboid if you want. So we've got this thing over here, and I'll just fill in the dimensions quickly. So everything here is in millimeters. We've got 19 millimeters, a height 74 millimeters, and they have this side over here as 18 millimeters. So this kind of can be a little bit confusing because now we've got a 19 at the top, a height, but we don't necessarily know the dimensions of all the sides at the top. Right? So did they give us everything we need? Yes, they did. Because we know it's a rectangular box, we know that this side must be the same as this side. So I'm actually going to re-label this, and I'm going to keep the 18 at the top over here. So now everything is where I want it to be. And when I'm finding the area of the lid, I can easily see that it's 19 times 18. Okay, remember it's a rectangle, so it's base times height, or length times width. So it's 19 times 18. I get 342. Our unit is millimeters squared. Okay, remember area and squared. So now to find the volume, I'm going to take the area of the lid, which is 342, and times it by our height, which is 74. I get 25,308, and our unit is millimeters cubed. Okay, so it should be fairly straightforward now. We're not really doing anything crazy in terms of the shapes we're trying to find. We're just dealing with the basics, circles, squares, and now we're going to move on to triangles. So the last shape is a prism. So the lid is a triangle, but it's one of those special triangles. It's got a 90 degrees over here. So if we turn this triangle to be flat, it would look something like this with 90 degrees. But because it's shown here in 3D, it's just a little bit tilted. Okay, still this angle is 90 degrees, even though it doesn't look like it. Okay, and let me fill in the rest of this. So we've got our units at the bottom. So we've got 5,6 centimeters, 6,8 centimeters, and 12 centimeters. Okay, so we don't need to worry if the labels are given at the bottom, because we know that this area for the lid is going to be the same as the area for the base. Okay, it's the same triangle all the way down from top to bottom. So I'm just going to work out the area of this triangle here. It's going to be the same as the lid. So area of lid. Don't forget our formula for triangles. It's a half times base times height. And the value of our base is 5,6. And our height is 6,8. Okay, now I'm working out area of lid. So that's the base and that's the height of this triangle. Don't get confused and use this as the height, okay? Because the height is relating to two different things. This is the height of the shape of the 3D object, and this is the height of our lid. So let's see what this gives us. You've got a half times 5,6 times 6,8. I get 19.04, and our unit was centimeters, so centimeters squared. So our volume is going to be the area of the lid, 19,04, times by the height, which is 12. That gives us 228.48. And our unit is centimeters cubed. Okay, so lastly, I'm going to look at some conversions and some units that we use for measuring volume. So far, we've just looked at volume in terms of lengths. So we get like it's in centimeters cubed, millimeters cubed, meters cubed. But next up, we're going to be talking a little bit more about liters and milliliters.